Hey, my name is Gayana Jayasinghe. I just finished my PhD at the University of Illinois, Urbana-Champaign, where I specialized in mathematics. Here's a bit about my journey. I grew up and went to school in Kandy. I went to Trinity College. I did chess and drama in school. I always loved mathematics as a child. So during my A levels, many of my colleagues and I, we were not aware of many of the opportunities that were available, such as applying for foreign universities or even how to choose an undergraduate degree after the advanced level. In that light, you have a golden opportunity with university professors coming to you and communicating with you about this. I think you should make the best of this opportunity. So, career guidance and a general awareness of opportunities is vital to being able to make informed decisions. And you should always seek out more information, even beyond the event that you're attending. For myself, doing engineering was more or less an informed decision taken after weighing various factors such as job opportunities in the country, as well as the ability to switch fields later on if I really wanted to. However, that may not be the best decision for someone who knows while in school that they really want to do mathematics. So it is a complicated decision, and you should really seek a lot of information and you should take an informed decision. I entered the Faculty of Engineering at Peradeniya in 2011, and I made the best of that time. I did my studies well, learning beyond just for passing exams, and I really mastered the subjects that I was learning. During my first day, I tried to absorb as much as I could about various topics, reading various books in the library, asking seniors about their experiences, so forth. Since I liked mathematics, I realized that I would have more exposure to topics I liked in electrical and electronic engineering, although computer engineering and mechanical engineering were also very close contenders. Um, I also started working on various projects and participated in many events such as coding competitions and electronic design competitions. And together with some friends, we actually won some of these things. I worked with old friends and made new friends, some of whom I still work with on various projects today. This includes projects where we teach students and teachers topics such as programming, Arduino, electronics, robotics. I also did some drama in university and chose swimming as a regular exercise. For my final year project, I was studying a problem in computer vision, mainly focusing on segmenting swimmers from various videos in various lighting conditions in swimming pools. I did this and wrote several conference papers. During my final year, I already realized that I wanted to study things more rigorously and decided to switch to mathematics. Thus, I started learning via online courses and used online material to study mathematics. I was helped a lot by many members of the staff at the faculty to switch my field. I did a brief stint as a temporary instructor at the Department of Mathematics at the faculty, where I caught up on the mathematics that I should have learned as an undergraduate. Um, a friend of mine also switched to physics, and we studied various things together. And we both managed to secure positions in highly ranked graduate institutions in the United States. While there was a certain amount of luck involved in this, a lot of work can take you a long way. My work now is in geometric analysis. I use heat flow, Schrödinger operators, and supersymmetric quantum mechanics on singular spaces to study geometry and topology of spaces. Some of the results I have proven can be used to compute quantities that physicists are interested in. These include formulas for entropy of black holes, for certain theories, which extend the work of physicists such as Stephen Hawking in some ways. Consider a torus and a rotation of a torus. We know that if we rotate a torus like this, it will not have any fixed points. If we have this two-dimensional surface of the torus, we can draw triangles all over this. If you count the vertices minus the number of edges plus the number of faces, this number will be equal to the number of fixed points of this group action, which is to say it will be zero. For the torus, if you do this for any sort of triangulation, this will be zero. But this happens more generally than just for the two torus. This is what is known as supersymmetric counting. If you count the number of vertices minus edges plus faces, this is other important features of the geometry. A deeper generalization of this is counting the number of bosons minus the number of fermions. This was used in classifying gravitational instantons by Stephen Hawking and Gary Gibbons. Engineering is focused on the built environment, how we can push the boundaries of what we can do within the physical world. Of course, this is intimately related to physics as well. Mathematics is the language that we use to understand what actually happens in the physical environment, as well as the built environment. Consider Jim Simmons, a brilliant mathematician who essentially invented machine learning to understand the highly complex money markets which are beyond the reach of simple models. Abstract ideas are key to understanding the world and creating a better environment for ourselves. Regardless of which direction you go in, you will need to understand how things are related to everything else. I wish you all the best of luck.